Hello friends, welcome back to my channel. Now in this video, we will continue our series of Let's MLOps. This will be our third video. And in this video, we are going to talk about Kubeflow and how to set up a Kubeflow pipeline. Now first, we will set up Docker and the Kubernetes cluster using Minikube. And then we will go ahead and install and set up the Kubeflow environment. After that, we will create a Kubeflow pipeline script. Now this script would load the data, it will pre-process the data, and then we will use the data to train a machine learning model, and then we will evaluate the machine learning model. So this is an end-to-end pipeline on Kubeflow. So please stick around for the entire video and let me know if you have any questions in the comment section below. Now like, comment and subscribe to my channel for more videos like this. Okay, let's get into the project. Okay, so for a code overview, first we have a pipeline script here, which is a Python file, .py file, called a Kubeflow pipeline. First, we will import some libraries. There's a dictionary list. These are Python dictionaries and lists. We import a DSL library from the KFP package. Of course, we will install this before we can import it. We also import the compiler. Now, the DSL is what helps us to isolate each step of our pipeline into a container. So you see DSL.component, and then we specify a Docker image right here that would isolate this whole load dataset process into a single container. And then if you go to the pre-processing step, you see the same at DSL.component. We will do the same for this and so forth. Now for the compiler, after we are done writing all the code, if you step to the bottom, you will see first that we will define a pipeline here, which basically puts together all the steps that we have above for all 4 steps. And then we will call the compile command here. So that's why we are importing the compiler up there. Also from the KFP package that we will install. All right. And then we need input, output, dataset, model, components. Now these input, output, datasets, model are important because each of our steps in our pipeline is running in a container. That when we load the dataset into a container and we store it as a data frame and we want to pre-process it, that means that the output of the first process, which is loading the dataset, which gives us the data itself, which is df right here, and we save it as a CSV, this output has to be available for the pre-processed data step. So the output of this container has to be available for this container. Same way, the output of this pre-processed step has to be available for training model container, because it's the training sets that we have here that we will use to train the model and so forth. So they are dependent on each other. So think of 4 containers, and the output of one goes to the next container, onto the next, onto the next. So that's the picture of how the pipeline will look like, and also why we need input, output, data sets, and model. Now let's go into the steps in detail. First, we will load the data set. We are using the iris data set, the popularly known data sets for flowers, predicted based on the petal width, petal length, and the sepal width, sepal length. Now you can see that I have import sub-process right here. Now that's because to run this inside this Docker image or this Docker container, we need pandas, we need sklearn to load the data set into this container. But this Python container comes from the original state. So pandas and scikit-learn is not installed in it. So what this does is to basically use pip to install these packages, right? Now, there's another way you can work around this. That's by taking the image that you want to use and patch it with the packages that you need installed in there, or the libraries that you need installed in there already. Now, if that is done, then you can use the container directly and it will omit these two lines. You just get rid of them. Okay, so it's really up to you on how you want it. Next, so after the load dataset is done, we will save the output into the output underscore csv.path. Now, we're using .path because this path is accessible to the next process, which is preprocessed data. Okay, so that will become an input for this container. Now we are using the same image right here, Python 3.9, and so this container takes over. And again, this is an independent process, so we need to install the libraries again because we need them to run these commands. And then we will import pandas, scikit-learn, and the standard scaler and train test split. Now this will bring back the data that we saved earlier. Okay, save it as df. Now this is just for debugging errors, just checking the shape and checking to see if there are any missing values in there. Now if there are any missing values in there, this small block of code will drop it, or it will drop that particular row with the missing value. This is basically going to do same for the target column. By the way, we are trying to do a logistic regression model, and so this is a classification problem. So there is a target column, and then we will standardize the data for the features. So we use standard scaler from the scikit-learn library, and then we use the train test split to split our data, 20% for test and 80% for training. That will split our data into 4 pieces, naming them xtrain, xtest, ytrain, and ytest. And we save that random state as the number 42. Now you use the random state so that when you run this entire code multiple times, that randomization that you get from the beginning is the same thing that's gonna persist. To ensure some consistency, we set a random state. You can put any value here. It doesn't really matter. And of course, this is just some debugging commands to check the shape of the xtrain, xtest, ytrain, and ytest datasets. We also check the missing values. And then we will convert each of those datasets into data frame. Now that will help us to easily view them and also help with the training of the model once we are ready. And of course, we have to save those 4 data points that we just split. So you send them to the path for outputs. That way, the train model step is going to pick it up as inputs. And these are data sets. So you specify data sets in the bracket. By the way, this is the train model step. And so we are going to have an output, which is going to be our model. So that's why we have this in here. Again, for training the model, we need pandas, scikit-learn, and we need joblib. Now, joblib because we need to save the model artifact. So this is why we need this library or package. First, we have the train data. This is xtrain. We have ytrain. And these are some debugging commands that I put in there, checking missing values and shape. And here is where you use the logistic regression to model our data. And then we will fit it with the xtrain, ytrain. And then we use the dump command in joblib to save our model to a model underscore output.path. So this will basically save the model in the same path that is accessible. Now after that, we are going to evaluate the model again with the same container. And of course, we need some inputs which were outputs of the other container, which is the training step. So that's why we have this in there. And then of course, these are packages that you need. I have matplotlib also added because I'm trying to generate some plots in here. Import all of them. And now we have the test data sets right here. So when we load the model from the model.path, we can now use that model for prediction using the text data that we have. Once the prediction is done, we can generate some metrics. And here we are trying to generate the confusion metrics and the classification report, because our model is a classification model, logistic regression. And so we can save the metrics to a file, and then we can generate the confusion metrics as a plot. Now, up to this point, we have 4 different containers, so you have to piece all of them together to work in tandem. And that's why we have to define the pipeline right here using the dsl.pipeline, and then we give it some name. Let's call it ml-pipeline. The first operation here will load the data. Second, we'll preprocess the data. Next, we will train it and then evaluate it. This compile command here is what's gonna compile the whole thing. We are gonna compile this .py file, which is the Python, and it will generate a YAML file. So that is gonna be the name of our YAML file when you compile it. So this is what is gonna be deployed onto the Kubeflow platform. Now, of course, I'm only doing an overview, but in the description below, I have the link to the GitHub repository with this code so that you can check all the tiny details of some of the names and the variables that I've used in there. All right. And if you have any questions, leave them in the comment section below, and I'll try my best to answer it for you. So that's pretty much the code that we're using for a pipeline. Let's get into the project. Now at this stage, we will look at how to set up our Minikube cluster. And so first, we need to install Docker. Now I've already installed Docker on my local machine, which is a MacBook. If you go to the applications, you see Docker right here. Now to run Docker on your MacBook, you need to install the Docker desktop. Now you can easily install that by going to your browser and then Google install Docker on Mac. So for Mac, you can install Docker using Docker Desktop. Whether it's Intel or Apple Silicon, either one still works. If you're doing this project on an Ubuntu machine, you can install Docker using the Docker engine for Linux. Ubuntu is right here. If you are running it on Windows, Windows also uses Docker Desktop, so just install the version of Docker Desktop based on your machine. Now, I already have Docker installed, so the only thing I would do is just open a new terminal. I'm gonna clear the screen here. So if I do Docker -- version, that's my Docker version that is installed. And I've already opened it, so it's running right here. So this is my Docker. Currently, there are no containers running. I don't have any images here. So there are no volumes here as well. Docker is running successfully. Now, since Docker is running, and we want to set up a Kubernetes cluster using Minikube, go to your browser and search for install Minikube. Now, if you click on that, you should see installation for Minikube. I'm currently on a MacBook, so you click on Mac. You can use the binary download, or you can use Homebrew to install it. Right. I prefer to use the binary, so you can copy these links and run them on your terminal, and that should install your Minikube cluster. So just copy this. But before I run it, I believe I have Minikube installed as well. So let's just do Minikube status. And it says Minikube not found. So to start a cluster, we need to use Minikube start. If I run Minikube version, so Minikube is already installed. So if you don't have it installed already, just copy these 2 commands here and run it, and that should install it. Now, since that is also installed, I'm gonna start my cluster using Minikube start. I'm gonna clear the screen. Now I want to use Docker container to create my Minikube cluster. So I'm going to use a driver. It's going to be Docker. Now this will ensure that my Kubernetes cluster or my Minikube cluster is running in a Docker container. So press enter. That should start creating it. Now you can see here that it's using the Docker driver, and our Docker is installed using Docker Desktop. So it's seeing it right here. So give it a few seconds and that should create the Minikube cluster. All right, so the cluster is done creating. Now, if I do Minikube status, you see that Minikube is currently running. Now, to interact with our Kubernetes cluster, I need to install the Kubectl command line package. And so on your browser, if you don't have it installed already, just go to install Kubectl. And that should be a few commands here. I'm installing it on Mac OS. If you have Linux, click this. If you have Windows, use this link. So on Mac OS, there are several ways you can install it. Homebrew, Mac port. You can also use the binary. Just run these commands and that should install your Kubectl for you. I already have it installed, so I will just check Kubectl version -- client. That should show you the version. And I got this command from the installation page. After installing it, you run this Kubectl version -- client. Same command, and that should show you your version that you've installed. Let's clear the screen. So Minikube is installed, Docker is installed, Kubectl is also installed. So if I do Docker ps, see that there's a container running called Minikube. This means our Kubernetes cluster is running as a Docker container. That's why it's showing up from Docker commands. Now, if I do Kubectl get nodes, you see one node, it's a control plane node here, and it's ready, and it's called Minikube. So this is our Minikube node, currently just one node. If you want more information about the cluster, you can run Kubectl cluster-info, and that should show you the control plane URL and that of the core DNS. Okay, now at this stage, since our pipeline code is in Python, so our file is .py, so it's a Python file. Let's clear the screen here. So you can decide to run it on your local system. So you need to have Python installed already on your local system. You can use Python 3 -- version to check the version that you have installed already. But because I don't want to use this, I want to create a virtual environment, which is a Python virtual environment. I'm just going to do that to isolate the virtual environment from my local system. So I'm going to create a Python virtual environment. And for that, I'm going to use the command Python. By the way, these are the files that I have in my directory currently. So these two files, right? So I'm going to create a Python virtual environment in this directory called Kubeflow 01. And to create that, I'll use Python 3 -m venv, which is virtual environment. And I'm going to give it the location path to venv. Press enter. Now you can see, we notice a new environment has been created. Do you want to select it for workspace folder? If you want to select it, sure. If you don't want to, I'm going to select it. I'll say yes. Now you can see there's a new directory here called path. Now you see path to venv, which was exactly this location that I gave. And you see bin for binaries, include library. And now this is basically like a virtual server of Python where you can run all sort of Python commands without having to use the one that is actually installed inside your local system. So if you want to check the version, you can use path to venv binary python -- version, and this is the version that is installed in the virtual environment. Now within this virtual environment, there are some packages that we need for running our pipeline that we need installed in there as well. One of them is KFP. Now you can see it here that KFP is underlined yellow right here because it's not installed inside this virtual environment, which is running Python. Initially, it wasn't there because KFP is actually installed on my local machine. So I need to install it inside this virtual environment. So to install it, I'm going to use path to virtual environment bin/pip install KFP. And this should install KFP inside this virtual environment. Okay, so installation was successful. And so KFP is installed. You see that it changed to green. And now the yellow underline that you saw earlier is not there anymore because this library or this package is installed successfully. Now with the virtual environment and everything set up, at this point, we are going to have to install our Kubeflow. So I will clear the screen. Now to install Kubeflow, go to your browser and you can search for Kubeflow local deployment. Open this link right here. Now there are several ways you can install it, and you can use it with kind cluster and so forth. Currently using Minikube. Just scroll all the way down. I'm going to use the one for Docker since we are using Minikube, which is running on Docker desktop. So as you can see here, you need to have Docker desktop installed and create a Kubernetes cluster on it. And we did that, and we checked using Kubectl cluster info, which showed us a URL for control plane and the core DNS. Now, once that is done, all you have to do is just run these commands right here. So you can copy them one by one. Export this. And then for the other three, they are Kubectl commands, so I'll just run them together. If you like, you can run them separately. Just copy them. Paste them here. Just run them. Now this will take some time, a couple of minutes, about 10 to 15 minutes. So just give it time and it will finish creating everything. So the first two have finished running and the last command is running at this point. Okay, so everything is successfully created. Right. Even though the commands are done running, let's go back to the page here. We can access our Kubeflow UI on our browser using this command. But at the moment, it's actually still provisioning the resources, right? And so it's not actually ready. So to see that, I'm going to go to a new terminal, just a different terminal here. What I will do is I'll run Kubectl get all inside the Kubeflow namespace. Now this is because when you're installing Kubeflow, it installs everything inside the Kubeflow namespace. Okay. Get this, and you should see all the resources that are being created behind closed doors for Kubeflow. Make this a little bigger. So there are parts, some of them are crash looping, but they are still going to be created at the end of the day. Some are already running, some are creating. There are services, there are deployments. See, some are ready, some are not. And then there are replica sets. Okay. So it takes a while, about roughly 15 to 20 minutes, depending on your system, to finish installing all of this, right? So I'll give it a few more minutes and come back once it's ready. Now you will have issues with crash loopback of errors, but it's because this container is actually dependent upon some of the other containers that are created. Okay, so actually be the last container that will be created. That's why it's doing that. All right, let's check one more time. Run the same command, and now you can see everything is ready. Now this took roughly about 22 minutes, as you can see here. So all the pods are ready, all the services, the deployments, as well as the replica sets. Can be well assured that Kubeflow is installed in a Minikube cluster. So I will clear the screen for now. And then what I'm going to do is to access Kubeflow on my browser. So for that, I'll run a kubectl port forward. And of course, we are running it inside the Kubeflow namespace. And I'm exposing the UI of our Kubeflow. So service. Now I need to check the name of the service that we are trying to expose. So Control C, and then I'll run the command that we ran it again. I'll go to services, and this right here is a service for the UI. This right here. You see ML-pipeline-UI, right? So I'm going to expose this port. It runs on port 80. So I'm going to run kubectl command. I'm just going to copy this here. And I'm going to run the kubectl command that I was typing earlier. So kubectl port forward in the Kubeflow namespace. And then the service name is ML-pipeline-UI, the one that I copied. And I'm going to port forward it to port 8080. Okay, my port 8080 is free on my computer. You can use any port. Now the original port for this service is 80. So use this command. Now this command has to be run inside the dedicated terminal, one that you are not currently using. So press enter, and it has started forwarding. So if you go to your browser, I'm gonna close these. I don't need them anymore. Close all of these. By the way, if you are watching, please subscribe to my channel. I'm a new YouTube channel that I'm trying to grow. So if you like my videos, please like, comment, and subscribe to my channel. So I'm going to use localhost for 8080. Press enter. And that should open the Kubeflow UI. Now, there's a problem usually with running Kubeflow locally. Sometimes the port forwarding command will exit or will refuse connection. Okay, so you may have to run it multiple times. Now, the reason why you see this red stuff showing error is because it exits out of the forwarding or the port forwarding, right? So whenever you see this, just rerun the command, and you should see that your Kubeflow should be back up and running. Now, these are some example pipelines that are created that you can check on. So you have pipelines, you have experiments, runs, recurring runs, artifacts, executions, and here are the documentations. You can also upload a pipeline script, refresh it, delete pipeline script, and so forth. So that is our Kubeflow environment set up and ready to go. Now, don't exit out of this port forwarding, so just leave it. That's why I mentioned earlier that you need to run it in a dedicated terminal. So that is the second one right here. So I'll keep this as it is. And then you will use another terminal if you need to run any other commands, right? So we will leave this as it is. Now go to a new terminal. So all the resources that we needed them to run for the Kubeflow to be active have all been created. So I can clear the screen right here. Now that everything is ready, our Kubeflow cluster is ready. Now it's time to actually first to compile pipeline code and then deploy it onto Kubeflow. Now remember earlier we created a virtual environment for Python. Now in the current directory, this is the virtual environment path or directory. This is our pipeline script, which is open right here. And this is a txt file containing some instructions. So to compile our code, you're going to use the command path to virtual environment bin Python. That's where Python is installed on our Python virtual environment, right? So if you want to run any Python command, you would have to type this whole thing, okay? And then the script that you are trying to run. So our script is Kubeflow pipeline.py. Now, say for instance, you're working on your local machine where Python is already installed. In that case, if you want to run this, you just run Python and then the file, the script that you're trying to run. So Python and then the name. But because you're using a virtual environment, you have to use this whole thing. So that was just by the way. So I'm running this and then Kubeflow pipeline.py. Press enter. And this will compile the .py file using Python. Now you see that it shows blue, so it's done. Now once this is compiled, if you check the files in the location, there's a new file created, which is Kubeflow pipeline.yaml. That is coming from, if you go to the script, scroll all the way down to the bottom. By the way, the script is attached in the GitHub repository link in the description below, so check it if you miss anything. Now, after compiling, this is what is created, and this is the file that is showing right here. Now, this file is what's going to be deployed onto the Kubeflow cluster. I'm going to clear the screen. This is our directory. And so to deploy our pipeline onto Kubeflow, don't forget Kubeflow is still running. The port forward is still running. So we use the command kfp. Remember we installed kfp package earlier. This package. So kfp pipeline create. Now you can use help to see some help commands for this kfp pipeline command, right? So these are the flags. You can use -p or -- pipeline -name to run a pipeline, or to set a name, and then -d for description. So you're going to use -p because we want to run a pipeline, and then you give a name for the pipeline project. So let's call it Iris. We're using the famous Iris dataset, so I'm going to call this Iris project. And then for the file name is right here, the YAML file, right there. Press enter. Now, when you press enter, you should see that the pipeline details here showing is created at this time. Okay. All right. So everything is deployed onto Kubeflow. Now go to your browser. Again, remember, this is still, the port forwarding is still loading, still open. Now refresh this, and you should see the Iris project that we just created. Click on this, and you should see this right here. So based on the code that we wrote, this is the layout we have for the graph. So we first load the data, output that data because the next process or the next container needs it. So we will use it in here. And then the preprocessed data will output 4 types of data. Basically the 2 training and the 2 testing data sets. This is 2 of them, and this is the other 2. But we need a training set for training the model. Now, after we train the model is created. We output the model right here because we need it for evaluation. And for evaluation, we need the test data, which is right here. Once we've evaluated, we are going to get some metrics as our output. Once this is done, you are ready to create a run for your project. All right, now at this point, since we have our project loaded in Kubeflow, and this is our graph, click on Create Run. Now this is the pipeline project, and this is the version. Give it some name, description. You can also choose some experiments that you want it to fall under so that you can easily track them. You can provide a service account to use and all that. I'll leave everything as default and just click Start. And that should start our run. So our run is going to start any moment soon. Now, don't forget the port forwarding command is still working, so it's still taking traffic. So the loading data step is almost done. If you click on this, you should see what's going on with that container. Okay. Some input outputs, some task detail you see are still running. And you can check some logs. Now, if you check the logs, you will see the schema and some packages that are being installed in here before the actual job is done. Right. That's why it takes a while for it to finish running. So give it a few minutes. Now you see that it's successfully done running. And now the output that it creates is output_CSV, which will be used by preprocess data step or the preprocessed data container. I will run it and it will generate these 4 outputs, the training and the test data. So that's almost there. Let's check the load data logs one more time. So you see that it finished installing all the packages and then it started running the actual script to generate the output for the preprocessed step. So this shows published successful. Now it's on to the preprocessed data container to finish its task as well. Okay, so the preprocessed step is also done, and you can see the yellow directories showing the test and the training data sets created. So the next step would be to train the model itself. Of course, we are training a model, so we need the training set. And you see the training sets just started as well. All right, so the training is also done, and you can see it generated an output here, which is a model itself that is being trained. If you click on this, you should see some logs, some details, as well as some logs right here. Here is the installation of some packages, and these are some print commands that I added to the script. This is the training data sets of the feature, and this is the training for the target variable that we are predicting. And here are a few more. The commands for the shape and missing values. You see 0 missing values here. And this is also published successfully. Creates this model output. If you click this, you should see some outputs here. All right. And now the model is evaluating using the test data set right here. That's why the arrows are pointing to evaluate model. And that should give you some output of metrics that are indicated in the code. Now in our code, if you go all the way to the container that is doing the evaluation, which is the last one, the number 4, what it's doing is predicting using the test data set, and then it's trying to generate some metrics, classification report, which would include accuracy, F1 score, and stuff like that, including a confusion metrics, right? So you should look out for that. So let's see. So you can see the evaluate model is also successful. You can click on this, you can check the logs. So this is the Y test data, or the test data for Y. And here are some metrics. So precision is 1.0, which is 100%. Now this iris dataset is very common and it's not a lot. So you see that a lot of the metrics here are 100%. Recall, F1 score, support, precision, and so forth. Check the logs. You should also see all the packages that were installed. These were artifacts that were carried over from the previous container. And these are the packages. And of course, this is the output. And these are the results or the metrics. You want to check where the artifacts saved or stored. If you go here to artifacts, you see all your artifacts right here for every single step. You have these outputs that were generated. And so each one has its own artifact. If you click on it, you should see an overview. You go to the lineage explorer. You will see the map written out here. If you click on any one of them, you should see more details about it, right? And you will see the URI also indicated right there. So that is how useful Kubeflow can be in machine learning, in AI. So it's basically a Kubernetes platform that is built purposely for running machine learning jobs, okay? And it uses the whole idea of container orchestration from Kubernetes to make things very easy. Now, if you want to run multiple jobs for this, of course, you can create new runs for the same project. Now, the first time it will take a little longer, but after that, the subsequent times, it doesn't take that long to run them. So you can create new runs, new experiments, and then basically generates more runs and artifacts from your pipeline. And if you go to pipelines, you should see all the pipeline projects that you have. If you create a new one on the terminal, it's going to appear here and you can use it. So this is how you would deploy Kubeflow in your local environment. So please like, comment, and subscribe to my channel for more videos like this. By the way, the link to the code that I used here is in the description below to the GitHub repository, so you can use it for your own jobs or for your own experiments. And of course, if you want to clean up, just exit out of the port forwarding, Control C, and then make this a little bigger. I clear the screen here. Docker PS. This is our Minikube container, so you can just do Minikube stop or Docker to stop the container. Either way is fine. So Minikube stop is fine, and that will shut down our Kubernetes cluster. All right, so it's shut down. If I do Docker PS now, you see that there's no container running. You go to the Docker desktop, you see that this is our container and it has stopped. You can click this to also start it. This is the image that you used, the kick-based image. And this is the volume that was attached to the container. Thanks for joining me again on this video. Please like, comment, and subscribe to my channel for more videos like this. And I will see you on the next one.